All right, we are continuing with lesson 9.3. This is task 3. Solve linear systems using elimination. Matthias tried to solve the given linear system by adding the equations. All right, so you can see 5x plus 4y equals 8 and negative 5x minus 4y equals negative 8. All right, so since these are opposite signs and these are opposite signs, they're going to add the equations together. So what happens when they do that? 5x plus negative 5x cancels, and 4y plus, that should be a negative 4y. They got a sign wrong there. But if you add these two together, you get 0, and then 8 plus negative 8 is 0. So when you add those two original equations together, you get 0 equals 0. All right, so select the correct word to complete the explanation below. What does his result show about the system? The identity 0 equals 0 means the equation represents the same line. So their graphs have infinitely many points of intersection. So if they're the same line, that means all points are going to be solutions. All points are solutions. Again, remember, they've copied this over. That should be a negative 4 there. All right, so Matthias then tries to solve the following linear system by subtracting the equations. 2x plus 3y equals 8. 2x plus 3y equals 1. All right, so this time these have the same positive signs. So this time we'd have to subtract instead of adding. So if you subtract the bottom equation, 2x minus 2x cancels. And then 3y minus 3y cancels, and then 8 minus 1 is 7. So we can see that 0 does not equal 7, so this time it is not a true statement. What does this result show about the system? The false statement 0 equals 7 means the equations represent parallel lines, so the graphs have no or 0 intersection points. All right, so you can see that these have all solutions. So this would be a dependent system. And the one here at the bottom, there's no solution. So this would be inconsistent system. All right, that's all for task 3. If you have any questions, let me know. Lesson 9.3, task 4. Apply systems of linear equations. All right, question 4. Jamie is paddling her kayak on a river. She first paddles downstream with the current from her campsite to a picnic area where she eats lunch. Then she paddles upstream back to her campsite. What is Jamie's paddling speed in still water, and what is the speed of the river's current? All right, so you can see in the morning, Jamie paddles 6 miles per hour with the current. In the afternoon, she paddles 2 miles per hour against the current. So, it's harder to go upstream. It's harder to paddle against the current than with the current. All right, so write this out verbally. Paddling speed in still water, we're going to call that P. And then the speed of the current, we're going to call the current C, equals paddling speed with current. Okay? So paddling plus the current equals 6 miles per hour. That's right here in the morning. And then in the afternoon, paddling speed in still water, P, minus speed of the current, C, equals paddling speed against the current, which was 2 miles per hour, given in the picture here. All right, so we've got P plus C equals 6, and P minus C equals 2. All right, so this is our system of equations. And we can see that P's have the same sign, C's have the opposite sign. So it would be very easy to quickly eliminate the C's by adding these two equations together and finding the answers. So if I did this kind of even in my head here, cancel these, I'm going to get 2P equals 8, divide by 2, and P equals 4. So very quickly I can see that P, paddling speed in still water, is 4 miles per hour. All right, so how do you know that you can add the equations to solve this system? You can add the equations because these variables have opposite signs. So the coefficients of P are the same, so adding the equations eliminates P. So we're not trying to eliminate P here. We want to eliminate C. So skip down to the bottom two. The coefficients of C are the same, so adding the equations will eliminate. They are not the same, they're opposite, plus and minus here. So the coefficients of C are opposite, so adding the equations will eliminate C. So that is the correct answer there. And then it says add the equations to eliminate C, then solve for P. So they did this right here, what I did in my head just a second ago, P equals 4. Once you find P, you can plug that back in and find C as well. So the current is 2 miles per hour. All right, so why does it make sense in this situation that the value of C is less than the value of P? All right, so if she paddles at 4 miles per hour and the current is 2 miles per hour, that means she can make it back upstream from her picnic area back to her campsite. If the current was faster than she could paddle, then she would have to find another way back upstream because the water would be flowing too fast. All right, so Jamie's paddling speed in still water is 4 miles per hour, and the speed of the current is 2 miles per hour. All right, that's all for task 4. If you have any questions, let me know. All right, guys, 9.3. Let's finish up here with a few examples. All right, so first, remember your steps to use elimination. You're going to add or subtract the equations in the system to eliminate one variable, and then solve for the variable that was not eliminated. Substitute the value of the variable you found into either original equation and solve for the other variable, and then write the solution as an ordered pair. So remember, an ordered pair is always x then y. All right. All right, so let's look at this example here. All right, so we have a system, 2x minus y equals 5 and x plus y equals 1. So when I look at this, my x's do not eliminate, but if I add these two equations, my y's will eliminate. So I'm going to add these two equations together. So you're going to have 2x plus x equals 3x. My y's cancel, and 5 plus 1 is 6. So now I can solve for x by dividing by 3. X equals 2. Once I find 2, I can plug it back into either equation and solve. So if I look at the second equation, I can just substitute 2 plus y equals 1. I'm going to subtract 2 from both sides. Y equals negative 1. So my ordered pair, or my solution, would be 2, negative 1. If I were to graph these equations and find the intersection point, I could do that, or I could use substitution from the last lesson or elimination from this lesson. So there's multiple ways to solve systems, and depending on how the system is set up, one way may be easier than another. All right, so let's look and make sure, let's check it and make sure that it works. So we're going to have 2 times 2 minus y, y is negative 1, equals 5. All right, so 4, negative plus negative is plus 1, 5 equals 5. So we can see that the ordered pair does work for the first one. Now let's check the second equation. 2 plus negative 1 equals 1. 2 minus 1 is 1 equals 1. So this one works as well. So I found the ordered pair, plugged in my x and y to check it just to make sure that it was correct. All right, let's look at another example. All right, so I have a system of equations. I can see that this is positive and negative, so I can add these equations. When I do, it's going to cancel here and here, so I'm going to have 0 on this side. 4 plus negative 5 is negative 1. All right, so that is not a true statement. So I know that this is no solution. So these would be parallel lines. These would not intersect. If you graphed them, you would see that they do not have an intersection point. So that one would be an inconsistent system. All right, let's look at this one. We've got x and negative x, so again, we can add these together. If I add these together, this cancels. 2y plus y is 3y. 13 plus 5 is 18. Divide both sides by 3. and y equals 6. Once we find y, we can plug that back in to find x. Again, either equation, it does not matter which equation you use. I'm going to use the second one just because it has smaller numbers. So negative x plus y, in this case y is 6, that equals 5. So if I subtract 6 from both sides, I've got negative x equals negative 1 divided by negative 1, x equals 1. So again, my ordered pair is always x first, then y. It doesn't matter which variable you solve for first, it's always x, then y. All right, then I want to plug it in and check it. So I'm going to plug in 1 plus 2 times 6. Y is 6. Does that equal 13? 1 plus 12 is 13, so that works. Now I'll check it for the next equation. So negative 1 plus y, does that equal 5? Negative 1 plus 6 is 5. 5 equals 5, so it does work for that one as well. So if you graph these, you would see that the intersection would be 1, 6. All right, let's see if we can do one more. All right, so we are going to look at this system of equations, and I'm going to see that I've got negative 2x and plus 2x. I'm going to add these equations together. I add them, and this cancels. This cancels. That means I've got 0. 7 plus negative 7, 0. That means this one is all real numbers. So this one has infinitely many solutions, all reals. That means these two lines are equivalent. If you multiply 1 by negative 1, you would get the other equation. You can see that those equations represent the same line. All right, that's all for lesson 9.3. If you have any questions on solving systems with elimination, please let me know.